So, hello everyone. My name is Malik Arslan Nisar, and I am a TA for this course, Kinematics of Mechanisms and Machines. So, this is a recorded session for the week 8 tutorial because we have already taken the live session, but due to some technical issues, I was unable to upload the recording. So basically, the recording uh, was not correct, it was a corrupt file. So that is why I am re-recording the session. The all the questions as we discussed in the live session, they are the same. So this will be a relatively a shorter session, and uh, whatever we have done in the class, I'll just go through it briefly so that anyone who needs to revisit the recording or watch the recording, so he can. So I think I can start. So during the week 8, you studied about the gear mechanisms and gear trains. So the questions are also based on those topics. So I hope my screen is visible. And in the first question, we have that in this simple gear train shown, the number of teeth in the gears are N equal to 60, NB equal to 18, and NC and ND are equal to 35. So we need to find the transmission ratio. Let me check if I can use a pointer here. Uh, so wait a minute. Hmm. Mm-hmm. Okay, I cannot see an option here. So I usually use my laptop. Okay, I hope this helps. Okay, so here we have that the number of teeth in this A gear is equal to 60, the number of teeth in B gear is 18, and here we have 35 and 35. So for the transmission ratio, what we need to find here, we know that this is a simple gear train, so W output, which is basically omega D, upon omega input, which is the omega of A, that will be equal to nothing but the number of teeth of A upon number of teeth of D, okay, with a minus sign, because it shows the direction of that omega uh, input and omega output is in the opposite direction. That is what the minus sign indicates. So this is a relatively simpler question, so you'll do it. It will be minus 1.74. Now then we move to the next question. So the next question was that in the compound gear train given in the figure, an input torque of tau A equal to 40 Newton meter is applied to a gear A in counterclockwise direction. Okay. So the number of teeth in gears A, B, C, D, E, and F are respectively given as 28, 65, 35, 50, 30, and 60. Right. Now, given that the gear train is operating at a steady speed, find the magnitude of resisting torque tau GB on the gearbox. Okay. So here we know that since the gear train is operating at a steady speed, it means that the torque balance must hold and also the power balance must hold, right? So basically the input power must be equal to output power. So which I have written here as input power plus output power should be equal to 0. Okay, we will take care of the signs itself in the equation. And the next is that the torque of A plus torque of F plus the torque of gearbox. We know that here the torque of A and torque of F will not be equal. You must have seen during the lectures also that whenever we calculate, the output torque is different than the input torque. So since the moment balance equation must hold, so there will be a torque from gearbox which will come into picture in order to make the net torque equal to 0. So firstly, what we need to find here is that in the torque equation, we have tau A omega A plus tau F omega F is equal to 0. So tau A has been given to us, but this omega A and omega F, this has not been given. So we need to find it. And we can do it so because we have the number of teeth for each of the gears, right? So what you can do is that here you can see that the gear A and gear B are in contact. So omega A upon omega B is equal to minus NB upon NA. Now for gear B and C, we know that since this is a compound gear train, both the gears are on the same shaft. So because of that, the omega of B will be equal to omega of C, which I have written here. After that, you can see that the gear C is in contact with gear D. So omega D upon omega C is equal to minus of NC upon ND, right? And now D and E are mounted on the same shaft, so their angular velocities must be same. And similarly for the last pair, which is the gear E and F, this equation must hold. Omega F upon omega E is equal to minus NE upon NF. So I'm not going into the detail of this. You know how we got this equation, right? We connected the uh, like basically for the both gears we use their pitch circles, and for the point of contact between the pitch circles the velocity must be same. So that is like how we equated and using the Arnold theorem, right, or Arnold Kennedy theorem, we got to this equation. Okay, So I'm not going into those details because that derivation part you have already done. So uh, after that, if you see, what we can do is, now here we have these equations, we will just multiply them and substitute for the values of omega b and omega d. So when I multiply them, these three equations, it comes out to be something like omega b upon omega a into omega c upon omega d into omega f upon omega e. And on the right hand side we have this. Okay, so here you can see that omega b was equal to omega c and omega d was equal to omega e, so they cancel each other and we get the ratio omega f and omega a in terms of the number of teeth, and all these have been given to us. So I have just named it as p for simplicity. So if we substitute this in this equation, okay, the value of omega f in terms of omega a, so you can see 40 omega a plus tau f into minus p, which is this, into omega a is equal to 0. So omega a will cancel, and then tau f should be equal to 40 upon p. Now you can evaluate this p because all the numbers have been given. So those who were present in the class, I asked them to do it, and when you find the value of p and divide it, so you will get the value of like divide 40 by that value, you will get the value of tau f, which is equal to 265.30. Now since you have gotten this value, we can easily use the moment balance equation. So tau a plus tau gb plus tau f is equal to 0. So the torque of the gearbox would be the minus sign of like the torque of a plus torque of f, which you can see is coming out to be 305.30. Okay, so after that we can move to the next question. Okay, so the next question is based on an epicyclic gear train. So here you can see we have a planet, a gear train, a planet, a ring gear and a sun gear. Okay, so the question is, as the ring gear in the epicyclic gear shown below rotates at omega r equal to 12 radian in clockwise direction. Okay, the number of teeth on the sun and planet gear are respectively as ns equal to 45 and np equal to 20. Find the angular velocity of sun gear, okay, if the planet gear is rotating in counterclockwise direction with omega p equal to 28 radian per second. Okay, assume the number of teeth per unit length of the circumference on the gear is equal for all gears. Okay, so basically the ns and np, basically the number of teeth on the sun gear and the planet gear, are given, and after that the omega of the ring gear has been given and omega of planet gear has been given, and we have been asked to find the angular velocity of sun gear. So we know that we can first solve for the, like we can separately solve for the sun and planet gear, and after that for the ring and planet gear. So in the first equation I am solving for the pair of sun and planet gear. So you know that it is equal to omega s minus omega a upon omega p minus omega a is equal to minus of np upon ns. So here omega a is not known, other than that omega s is also not known, omega p is known, and np and ns are known. So from here we get this equation. Okay, so I'll call it equation 1. Now when I solve for the planet and ring pair, okay, with this as the arm, okay, the arm will be the same. So I can write omega p minus omega a upon omega r minus omega a is equal to nr upon np. So we have derived this in class as well, so you know why here we do not have a negative sign. So here NR and NP both are given, so it is 85 upon 20. And now, yeah, now what do we have next is that omega A is again not given, omega P is given, and omega R is also given, right? So uh, we can simplify this equation, okay, and we'll get it because omega P and omega R both are given, so only omega A will be remaining. We can calculate that from here. Yeah. So okay, wait a minute. NR is not given, right? NR is not given. NP is given and NS is given. Okay. So NS and NP is given, but we can relate NR as well. Why? Because see here we know that this is our whole assembly. So this is RS, which is basically the radius of the sun gear, and this is RP, which is basically the radius of the planet gear. So you can clearly see that RS plus 2RP will be the radius of the ring gear. Okay, and we know that the uh, NP, NR, and NS is basically proportional to the radius of the respective gears. So because omega, say omega R upon omega S is equal to NS upon NR, which can also be written as RS upon RR, right? So we have seen that. And here also NR is actually not given, okay, so I had just substituted it from the next slide. So we can write R of basically the radius of the ring gear is equal to radius of the sun gear plus twice radius of planet gear, and since they are proportional, so the equation comes out to be this, and from here we get the value of the number of teeth in the ring gear, 85, which I have substituted here. And when you solve this, you can see clearly only omega A is the missing variable, like only omega A is the variable. So you can calculate the value of omega A from here, then you can substitute that value in equation 1 and solve for omega S. Okay, so that is what we have done here. We calculated the value of omega A, which was coming out to be minus 24.30, and after substituting it back in this equation, okay, we got the value of omega S equal to minus 47.65. So sorry, you can yeah, basically try it for yourself. Okay, I'm just giving you the idea. The calculation, etc., you can do. Now we have this another question. Okay, so it says that the input shaft of the compound gear train shown below is connected to an electric motor rotating at 650 rpm. So basically the omega input is given to us, and determine the magnitude of angular velocity of output shaft if the number of teeth on the individual gears are given as n equal to 72, n b equal to 95, n c equal to 20, n equal to 35, and nf equal to 28, and ng equal to 52. So okay, this is basically a different representation of the gears which is given in the question. Other than that, omega input is given, and we have to find omega output, and others are also given. Now I'll just explain this representation. So you can see that this is an input shaft and this is a gear. So this is gear A. Now gear A and gear B, they are connected, okay, and gear B has a different shaft, right? So that is what I have made here. Now see, gear B and gear C are connected by the same shaft, okay, and so this is what I have drawn here. Now gear C and gear D, they also have different shafts which I have shown here, and gear D is connected to gear C. So that is why I have shown a contact here. Now after that, D and E are also again uh, connected in series here. Then uh, E is again connected with the same shaft as F, right? And F is connected to the gear G, so which I have shown here. Okay, they have a contact here, and G has a different shaft. Now if you can simply write the equations, omega A upon omega B is equal to minus NB upon NA, right? Omega B will be equal to omega C. Omega D upon omega C is equal to minus of NC upon ND. Omega E upon omega D will be minus of ND upon NA. And omega E equal to omega F, and omega G upon omega F is equal to minus of NF upon NG. So this is like very simple. You can write it. Okay, try to do it for yourself. Then after that, I have just multiplied all four of them. So some of the terms will get cancelled because C omega B is equal to omega C, right? Omega D is same, then omega E and omega F are equal. Okay, from these relations you can see. So on the right hand side also we get we get something in terms of NB upon NA into NE upon NC and NG upon NF. So now since I need to find omega G, I have taken this to the right hand side. Okay, or I basically have just taken the reciprocal. So these terms come to the denominator, these come to the numerator, and all of these values have been given. So you can easily find omega G equal to 151.578 rpm. Okay, which is basically the omega at output shaft. Now what we can do is we can go to the next question. So here also a compound gear train is shown below, right? And the input torque is given to us, and okay, so the input torque is applied in the clockwise direction, and we know that the clockwise direction is negative, so you have to take care of these things for like you have to take into account the sign of the torque and the omegas. Okay, so that's why I have written here that tau A or tau input is basically minus of 15.70. Now the number of individual teeth, the number of teeth on individual gears are given as NA, NB, NC and ND, they are given. So determine the magnitude of torque transmitted by the output. Okay, we know that the torque, we can use the power balance equation here. So the torque of input into omega input plus torque output into omega output should be equal to 0, must be equal to 0, right? So that is what I have written here. Okay, now we know the value of tau A, we want to know the value of omega A and omega D. Okay, so we can do that as we have done in previous questions as well. These two are connected in series, so omega A upon omega B is equal to minus NB upon NA. Omega B and omega C are mounted on the same shaft, so the velocity will be 0, angular velocity will be 0, and omega D upon omega C is equal to minus NC upon ND. Using these three equations we can get the relation between omega A upon omega D. So the ratio is coming out to be like you can substitute for these values, and simply you can put here the value of tau D, the value of tau uh, D, you can substitute the value of tau D, you can substitute the value of tau omega D. Omega D you can get from here, okay, taking its reciprocal in terms of omega A. Now omega A will be cancelled out, and tau D can be we can get tau D in terms of tau of A, so that will be equal to 145 into 115 upon 180 into 54, right? Wait a minute, have I substituted the value of, yeah, so I have divided this whole thing by 515.70, and we get the value of tau d is 9.15. You can try it out. Okay, these are just algebraic equations you have to solve. Okay, so that's not a big deal. So try these questions. Now we go to the next question. Okay, so we have been shown a gear system here. Okay, we have a gear 2 and a gear 1, and satisfies the fundamental law of gearing. Okay. So yeah, so in this question, the gear system shown below contains two gears, gear 1 and gear 2, and satisfies the fundamental law of gearing with n as the common normal. The circles represent the pitch curves of the respective gears, and AB is the common tangent to the circles. The pitch circle radius of gear 2 is O2P equal to 8.5. The pressure angle is 37 degree, and O3M is given as 4.6. So find the transmission ratio omega 2 upon omega 1. Okay, now here firstly two gears are given, and they satisfy the fundamental law of gearing with Mn as common and normal. So we know that the fundamental law of gearing says that the common normal, which is given as Mn, so this common normal, or we also call it the line of action, it must pass through a fixed pitch point P. Okay, and this pitch point P, it must also lie on the centers, lie on the line which connects the instantaneous centers of the two gears, for a constant transmission ratio. Okay, so this P must be a fixed point. And we know that you know how we derived this thing in the class lectures. You must have gone that through that, the point O2, which is shown as a hinge, and the point O3, these are the two instantaneous centers, and we join them using a straight line. Then we know that this point P must lie on the same line as well, and from that we made you did some geometry. Okay, and taking the velocity of the common points. Okay, we get to the final result. Okay, wherein we see that the omega of 2 upon omega 1 must be equal to minus of O3P, which is this distance O3P, upon O2P, or it is equal to O3 M upon O3 O3 m upon O2n, right? Now, so here omega 2 upon omega 1 is equal to minus O3p upon O2p, and O2p is given to us as 8.5, so we need to find O3p. Now, in order to find O3p, okay, you know that this angle phi is given to us, which is the pressure angle, the angle between the normal and the uh, tangent to the circles. So this is phi, so this angle here, it should be equal to 90 minus phi, right? So for this angle, for this triangle, we can write sine of 90 minus phi is equal to 4 perpendicular upon this hypotenuse, which is O3p. Here this perpendicular distance is given in the question, so we can find sine of 90 minus 37 is cos 37 is equal to 4.6 upon O3p, and this O3p we get as 5.76, right? Yeah, that's right. So we get its value as 5.76. You can check it for yourself also. So basically, in order to just give a background view how we derived this formula, it is already mentioned in lectures, you can watch that. But here what we did was that this point, let me call the point of contact between the two gears here, this point as C. So what we know that the in order to for maintaining contact between these two gears, the C should have like the relative velocity of this point must vanish, right? The relative velocity, there shouldn't be not a relative velocity present here, right? So what we do is that we try to write the velocity of this point C, which is a part of the gear 1 as well as the gear 2. We write the velocity in terms of gear 1 as the omega of 1 into this distance, okay, the distance O2n, and here we write it as omega c as omega 2n, omega 2 into O2n, right? So and we basically this point VC, we know that we VC3, which is basically for this, okay, this point I have denoted as 3, so that is why if I call this as VC3. So for this the normal component of VC3 will be equal to Vm, okay. There is a like I have made this red line as thick, otherwise there is a distance between the point C and this normal point M. So this Vm velocity here should be equal to Vc3n, which is the like I have called this as the common normal n. So the velocity of point C on this gear along its component along this n should be equal to Vm. Why? Because in a rigid body, because they are on the same rigid body, so the velocity between these points should be equal, like should be same, okay, because I am taking n as the common normal. So velocity of point C, the velocity of point C 3 in the normal direction should be equal to velocity of m. Similarly here also the velocity of point n should be equal to the velocity of point C as a part of 2, so I'll call that vc2n. Okay, so they should be same. So that is why I have written oh, that vm is basically equal to vn is basically equal to vc2n. So that's why I wrote the velocity of this point, and that velocity vn I wrote as o2n into omega 2. Okay, that is straightforward. Similarly here also I have just substituted for vc3n as vm, and then vm I wrote as omega 3. You can call this omega 3 or omega 1, whatever. So omega 3 into this distance. Okay, so that is how we arrive at the this equation. You can also check it from the lectures. So that is how we derive this relationship, and rest we discussed. Okay, so it shouldn't be that difficult. Now, okay, like there are yeah, sorry, play. Okay, so we have this last question here. So again, in the epicyclic gear train, we have an epicyclic gear train shown where we have a sun and the a ring gear, sorry. So the sun ring has 50 teeth, which is ns, and the ring gear has 100 teeth respectively, with a as the arm. Okay, the sun gear rotates at an angular speed of omega s equal to 7 radian per second in counterclockwise direction. A counterclockwise torque of tau equal to 24 is provided to the arm, which is rotating at omega a equal to 4 radian in counterclockwise direction. Determine the torque transmitted by the ring gear. Assume number of teeth per unit length of the circumference on the gear is equal for all gears. So you can see this assembly given here. We have a ring gear in which we have a sun gear and a planet gear, right? The planet and sun are connected by this omega this arm, and also the planet and ring are also connected by the same arm. Like this is the common arm for the connection between ns this sun and planet, as well as ring and planet gear, right? So here omega s is given, tau a is given, and omega a is given. Ultimately we need to find the torque transmitted by the ring gear. So we know that we are going to use this equation, which is the torque balance. So that is tau r plus tau s plus tau a is equal to 0. Now tau a is given, so first we need to find the torque tau s. So if you see the sun gear and the planet gear, okay, you know that tau a omega a is given, omega s is given, and other than that ns is given to us. Okay, so what we can do is first so since okay, omega s is given, ns is given, but np is not given. Okay, so ns and nr are given. So in the question you can see that the number of teeth on the sun gear and the ring gear are given, so we can get a relationship between omega s and omega r. Okay, so we'll first solve for that. So you can see that sun, for the sun and ring gear, omega s minus omega a upon omega r minus omega a is equal to minus nr upon ns, in which omega a is already given to us, which is s4 in the counterclockwise direction, and omega s is also given, and these number of teeth are also given to us. So we find the value of omega r. Now that we have the value of omega r, okay, what we can do is that we can write the power balance equation as tau r omega r plus tau a omega a and tau s omega s is equal to 0. Now tau okay, so tau r is not known to us, so we have omega r, which we just found out, and we have omega a, which was already given, tau a was already given, tau s and omega s is already given, and tau s is not known. Okay, so this is the what we get from the power balance equation. Here we have two variables, tau s and tau r. And now recall, we have the moment balance equation as tau a tau s, tau a plus tau s plus tau r is equal to 0. Here also tau r is known, tau a is known, which is as 24, and this tau s and tau r are variables. So then we have two equations in two variables. Okay, this equation and this equation, the only two unknowns are tau r and tau s. You can solve for these equations, and when you do that, you will get the value as tau r equal to -16 and tau s is equal to -8. So basically this minus sign represents that the torque on the ring gear will be in clockwise direction, and the value will be 16 Newton per meter. Okay, so this is what we discussed in the classes. This contains almost all the topics that were covered during the week 8. Okay, the simple gear train, compound gear train, then the epicyclic gear train, and also the pitch circle, etc., which was discussed in the first lecture. So this is the last session for this course, and I wish you all the best, and thank you very much.